Alright, continuing on with this section, I would like you guys to take a look in your book at page 202, analyzing the graph of the function. Just take a look at that page. And also I'd like you to look at page 204, how to find a slant asymptote. And what I want you to take note of is that slant asymptotes occur when the rational functions having no common factors, degree of the numerator exceeds the degree of the denominator by 1. What does that mean? Well, let's go ahead and use this example. Notice how the numerator's degree is 1 higher than the degree of the denominator. So there's a chance for that slant asymptote to occur. This is what a rational function is. It's a fraction with two functions being divided. How do you find the slant asymptote? Well, the way we find slant asymptotes is using long division. So I am going to go ahead and divide these two functions. So I will say that x goes into x squared, x. So x times x is x squared. X times negative 2 is negative 2x. Then what I'll do is I'll subtract this off. And when I do that, I end up just getting 0. But I have to bring down this 4 yet. So what I'm really thinking about is just how many times x goes into 4, which it doesn't. So if you remember anything from Algebra 2 and your long division, you would just say your answer would be your, I can't think what that's called, the remainder over the divisor. Sorry, I couldn't come up with that name right away. Where the slant asymptote is just this part that divided out. So our slant asymptote would be y equals x. So that would be this line of a graph. I will not get through this next example probably on this video, but I will get it started at least. This is the first time we're going to be analyzing this graph and finding everything. We're going to find the intercepts, the extrema, the points of inflection. We're going to find the asymptotes. So there's a ton of things we're going to be looking for. And so I will create a list off to the side of those things that we find. Let's go ahead and just do them in order. Let's find the intercepts first. So we're going to find the x-intercept. I'm going to be writing really small because there's a ton of things we're going to be doing on this slide. And when I compute the x-intercept, I will find that it occurs at 0, which means that I have an intercept of 0, which means that my y-intercept is also 0. So one of the things that's on my graph, and I'll just kind of make a list here on my graph. This would be important points. 0, 0 is an important point. It's an intercept. Looking at the next thing we're going to find is relative extrema, and we know that those occur at the first derivative. So we do need to find that first derivative, so I'll start to do that right here. I have to use a quotient rule. Bottom times the derivative of the top minus the top times the derivative of the bottom all over bottom squared. This ends up giving me 2x cubed plus 6x minus 2x cubed all over x squared plus 3 quantity squared. Those cancel and I'm left with 6x over x squared plus 3 quantity squared. Remember, I'm looking for places where the bottom gives me 0, so where critical numbers would be where the bottom gives you 0, which there is no values, or where the top gives you 0. Which, once again, we get x equals 0. Where I found out that x equals 0 is the intercept, well, it happens to also be a critical number. What that means is that we're going to have to test this interval. So y prime, we're going to test 0. We're going to plug in and find out what's going on with the slopes of the tangent lines. Well, when I plug in 1, I end up with a positive, and over here, when I plug in negative 1, I end up with a negative. So that means it's decreasing and then increasing here. If it's decreasing and increasing, I now know that 0, 0 is a minimum. I will continue this with the next video.